Okay, let's look at some properties of these pair of functions in front of us. And of course, they are inverse functions. You can see y, or f of x, I should say, equals e of x graphed here, and g of x equals ln of x, or log base e of x graphed here as well in pink. And you can see the clear symmetry about the line y equals x, which remember, if you see that by comparing a pair of graphs, if you see that symmetry, you should suspect inverse functions. And another way we can confirm that these are inverse functions is compose both of these functions in both orders. And of course, if they are inverses, they should undo each other, and your input x should become your output as well. So let's do that. We'll do g of f of x. So f is going to go inside of g of x. Remember, f is the inner function. Of course, this is setting us up for our chain rule after we get through this video, but for now, let's go g of f of x, form a composite function. We will say this will give us ln of e to the x. And if you remember how to manipulate a logarithm, of course, an exponent can come down front. The property, the so-called power property of logarithms, exponent comes down front, and then you're left with ln of e, which of course is 1, so we have x times 1, and that confirms our suspicions that yes, these are inverse functions because our input, which was x, is left unchanged as the output. So if I put 2 in here, this will all yield the number 2. If I put 5 in there, we will get 5. And yes, if I put something weird like pi in there, ln of e to the power of pi will just become pi. Okay, for our second composite function now, if we do it in the reverse order, putting g inside of f, this one's a little weirder, hence the review. We'll put ln of x inside e to the x. So this will give us e, and in the power we have natural log of x. So just based on what we did for the first composite function, we would suspect that this, through a leap of faith, is somehow equal to x, which of course it has to be because they are inverse functions. And remember, that output has to be the same as this input. Let's see if we can justify that a little bit better than just saying leap of faith. So let's just assume that e to the power of ln of x is equal to x. And of course, that's as in exponential form. It's hard to see that as an equation, but if we rewrite it in logarithmic form, we can actually see that this is an identity that will hold. And writing this in a in logarithmic form, of course, we'll use base e. Maybe we'll get a different color here to remind ourselves that if we're going to write something in logarithmic form, the log is equal to the exponent. So my exponent is going to be the output here, which is ln of x. And then going to a log, of course, we'll introduce a log, excuse me, a log base e. We'll rewrite that in a few more seconds. So log of base e of that x over here is equal to the exponent in that exponential form. And that is actually rewriting this exponential form in logarithmic form, and we can see that, of course, on the left-hand side, that's ln of x equals ln of x, I guess, with the box as well, if for some reason that's helpful. And we can definitely see that we have an identity here that makes a lot of sense. So we can trust our assumption that if you encounter e to the power of ln of x, that's always equal to x. And let's see if we can explore that with a couple of specific examples to help set us up for going back to our chain rule here in a few more moments. So if I drag this up with some success, amazingly enough, let's just change colors here, at least attempt to. There. Let's look at a couple of examples, like what is e to the natural log of 2, using that second composite function identity more or less at this point. Then of course that is equal to 2. That makes a lot of sense based on e to the power of ln of x always equals x, which of course is the input in that natural log trapped in that exponent. So if we do a couple more quick ones here, how about e to the power of ln of 3? That's the same as the number 3. And if we want to do something strange like e to the power of ln of pi, well, guess what? That is pi. And you can confirm that on your calculator quite easily just by typing that in to see that, yeah, if I see e to the power of ln, then whatever is that input inside my ln is exactly what the output of that confusing expression is going to be. Okay, so that's a bit of a recap. We're going to, of course, concentrate on that second composite function as we proceed back to the chain rule in the next video.